Morning, people. All right, we're finishing off the notes on Unit 3, assignment number 4. If you were in class, bye. If you were in class, we did the probability with the deck of cards. We did the probability with
Isaiah
spinners.
Salazar, please report
Now
to
let's
attendance
go
at
over
this time. Isaiah Salazar, please report to attendance.
area models and how to write the expression as a sum and as a product. And then let's go over Pythagorean theorem. Okay. All right. So an area model, let's set this up right here so we can fill out the area model. Let's go ahead and start with this rectangle. Let's mark the top of the rectangle as being the expression 5x plus 6. Let's mark the side of the rectangle as having the expression 3x minus 2. Because we have an addition sign up at the top, we're going to divide the area model in half vertically. And because we have two different terms on the side, that means we have to divide the area model in half horizontally. Okay, so what we're going to do is we're going to multiply. So keep in mind that whenever you're filling out the inside rectangles of an area model, you always multiply the top of the individual rectangle with the side of the individual rectangle. So for this top left rectangle, we would multiply 5x with 3x, and that is 15x squared. Okay. To get the top right rectangle, we're going to multiply the positive 6 with the 3x, and we're going to write that result in the rectangle. That's 18x. To figure out what goes in the area model of the bottom left rectangle, we're going to multiply the 5x with the negative 2. That is negative 10x. And then to get the bottom right area model rectangle, we're going to multiply the positive 6 with the negative 2. And that gives me a result of negative 12. So this is our completion of our area model. Okay, so now what we're going to do is we're going to express this as a sum. We're going to write this area model as a sum, and we're also going to write it as a product. Okay, so let's start off with sum here. So as you know, the word sum, whenever you see that in a math class, that means that implies addition. Okay, so what you're going to do to write this area model as a sum is, all you're going to do is take the 4 inside terms, or inside expressions, the 15x squared, and you're going to add it with the 18x, and you're going to add it with the negative 10x, and then you're going to add that with the negative 12. So the sum is just going to be the expression of all of the terms inside each of the individual area rectangles added together. Okay, now that would be your answer for the sum right there if there's nothing that could be combined that are like terms, but you can see that I have this positive 18x. It is a like term with that negative 10x, so I want to combine those two together. So the actual sum of my area model would be in simplified form, and it's not correct unless it's in simplified form, would be the 15x squared. I'm going to combine the positive 18x with the minus 10x. That's going to give me a positive 8x. And then I'm going to put this minus 12 at the end. And if you put plus negative 12 at the end, or if you just put minus 12 at the end, that is fine. Okay, so that's going to be my sum. Now let's go on to how do you express this area model as a product. Okay, now the word product in math implies that there is multiplication going on. Okay, and so what we're going to do to express this area model as a product is to express it as a product, you focus on the outside dimensions of the area model. So you focus on the 5x plus 6, and the 3x minus 2. And what you're going to do is you're going to express that as being multiplied together. So you're going to start a parentheses, and inside the parentheses, you're going to write one of the expressions. I'm going to write the 5x plus 6, and then you're going to close out that parentheses. And then the word product means you're multiplying, so you're just going to start another parentheses right next to that one, and then you're going to write the 3x minus 2 inside that second parentheses. So expressing this area model as a product would be the quantity, 5x plus 6. Quantity is just a fancy way for saying we have parentheses multiplied with the quantity 3x minus 2. Okay, all right, let's go on to Pythagorean theorem. We all know Pythagorean theorem as a squared plus b squared is equal to c squared. And the key part about the Pythagorean theorem is the c part is going to be the hypotenuse of your right triangle. And then the a and the b parts are going to be your two legs of the triangle. Okay, so these are going to be your legs of the triangle. Now, Pythagorean theorem, here's the key in it. It only works in right triangles. Okay, so you have to have a right triangle in order for Pythagorean theorem to work. And the C part is always the hypotenuse. The hypotenuse is always across from the 90-degree symbol. And then the A and the B are the what we call the legs of the right triangle. Okay, so and what you do is you use Pythagorean theorem to find a missing side. Okay, in a right triangle. So this theorem is used to find a missing side. Missing side in a right triangle. Okay, that's one of the uses for it. There's a few other uses for it, but we're going to focus on finding a missing side. Okay, so let's go ahead and let's say that I have this right triangle, and let's say the hypotenuse is 26, and then one of the two legs is 10, and then the other leg is an unknown value, which we'll refer to as the variable x. Okay, so we're gonna notice we have a right triangle. We're gonna use Pythagorean theorem to find the missing side of the right triangle, which is x. Okay, so we're gonna use a squared plus b squared is equal to c squared. C is the hypotenuse, so in the place of c, I'm going to substitute the number 26. And then a and b are the legs, which are 10 and x. So in the place of a, I'm going to substitute 10. In the place of b, I'm going to substitute x. Okay, now, if I substituted x in the place of a and 10 in the place of b, it would not affect my final answer. Okay, but the key is that you absolutely, positively, when you do Pythagorean theorem, in the place of the c value, you have to substitute the hypotenuse. Now we are going to work this out. We're going to simplify it, and then we're going to solve for x. Simplifying 10 to the second power is 100, plus, I cannot simplify x squared yet. That is going to be equal to, and 26 to the second power is 676. Okay, now, in order to simplify to know what x is, I have to get the x by itself. So my next step would be to take away 100 from both sides of the equation. Those hundreds would cancel out, and then I would have the equation x to the second power is equal to 576. And then if you recall, and I'm going to work it out over here, if I know that x to the second power is equal to 576, to figure out the value of x, all I do is I take the square root of 576. That's what x is going to be equal to. Okay, and that when I work that out, 576, the square root of it is going to be equal to exactly 24. Okay, so there we go. Pythagorean theorem in a nutshell.